This is the lecture for lesson 33. This lesson is going to cover systems of equations in two variables, and we're going to start with determining whether an ordered pair is a solution to our system and solving systems by graphing. To determine whether we have an ordered pair that is a solution, all we have to do is plug in that pair of points, the x and the y, into the equation to make sure that the left-hand side equals the right-hand side. In the first problem, we want to determine whether the point -3, 5 is a solution to the system. So -3 is going to go in for x and 5 is going to go in for y. And in the first equation, when I do that, I want to get the result of 8. And in the second equation, I want to get the result of -69. It has to work for both equations for this to be a true solution. So 9 times -3 plus 7 times 5. Well, 9 times -3 is -27. And 7 times 5 is 35. -27 plus 35 does give me 8. So that one works. Plugging in the next one, 8 times -3 minus 9 times 5 is going to give me -24 and a -45. If I combine those two together, I do get -69. So yes, this is a solution. Number 2 wants us to determine whether the point 8, 5 is a solution to the system. So now we're going to plug in 8 for x and 5 for y. So in the first one, 5 times 8 minus 4 times 5, our goal is to get 20. Well, 5 times 8 is 40. And minus 4 times 5 is 20. That does give me 20, so that one works. Check the second one, 3 times y. So 3 times 5 has to equal 2 times 8 plus 1. 3 times 5 is 15. 2 times 8 is 16. 16 plus 1 is 17. Oh, this one does not work. So overall, no, this is not a solution for the system. So remember, in order for it to be a solution for the system, it has to work for both equations. Next one wants us to determine whether the point 3, 3 is a solution. So 3 for x and 3 for y. So 3 plus 3 times 3 is going to give me 3 plus 9, which gives me 12. So it doesn't even work on the first one. No, it's not going to be a system or a solution to the system. So what are we doing here? Well, we are looking at two equations and trying to determine their solution. Well, in order for them to have a solution, we are looking for where the two lines cross. So looking at question 4 here, when solving a system of linear equations by graphing, the system's solution is determined by locating the intersection. So what we're trying to do is we're trying to determine if these two lines cross. And if they cross, where they cross at the intersection, whatever that point is, x, y, is the solution to the system. Now, not all pairs of points or all pairs of lines will intersect. There is the case of having two parallel lines where there will be no intersection and therefore no solution. And we also have the option where the first line is exactly equivalent to the second line, just written in a different form. And this one then has all solutions that work or infinite solutions. There will be a few ways that we can discuss that. What we're going to do now is solve a system by graphing. In order to solve by graphing, we need to make sure that both of the equations are in y equals form. Well, this bottom one is in y equals form, so I can go ahead and graph that. The number that is by itself is the y-intercept, so 2 is where I'm going to hit the y-axis. And then the number attached to the x is the slope. So -3, you always want your slope as a fraction because slope is always two directions, up or down. and then right. So from this first point, I'm going to move down 3 and over to the right 1. I'm going to do that again. Down 3 to the right 1, down 3 to the right 1. And then if you want, you can do the opposite going back. So then up 3, back 1. So I've gone and graphed that first line. Now the second line, what I'm going to need to do is I need to solve it for a y. So this one's not solved. So the first thing I have to do is subtract the x piece to the other side. So I now have 2y equals 7 minus 6x. Now if I divide everything through by 2, y equals, this is 3.5 minus 3x. So here's your y-intercept. So I'm going to start at 3.5. 1, 2, 3.5. But look at your slope now. The slopes are exactly the same. And in two equations where the slopes are exactly the same, the two lines are parallel. So if I do this, go down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1, you're going to see that I'm never going to cross the other line because they have exactly the same slope. So this has no solution. There is no place that two parallel lines will intersect. So the next system we're going to solve is 2x plus 5y equals negative 4 and 3x minus y equals 11. Now, I went ahead and I tried to solve this by hand. And when I did that, I got one equation, y equals negative 4/5 minus 2/5 x. And the other equation was y equals negative 11 plus 3x. Now, this bottom one here, yeah, I could graph that. But this top one here, graphing this negative 4/5 and then moving down 2 and over 5 is going to be really difficult. Okay? When they're not nice round numbers, it is not nice to graph these by hand. So what I'm going to do is I'm going to show you in Desmos from the original equations how you could do this. So what you can see here is I've gone ahead and typed the original equations into Desmos. And you can see the first line is in red, the second line is blue. And if you needed to, it does give you some nice points here so that if you had to draw this graph by hand or in your homework, you'd be able to get 2 nice points to connect your line. And the same is true for the blue one. We've got points we can get on the line. The nice thing then too is if you hover your cursor right over where the 2 lines intersect, it will tell you where they intersect, what the solution is. So the solution for this is 3, negative 2. Now we're also going to solve systems of equations using substitution and elimination, which our book calls addition, and then talk about inconsistent and dependent systems of equations and express the solution of those dependent equations. In order to solve a system by substitution, what you need to do is you need to have one of your equations solved for a variable. And it doesn't matter which variable you solve for. You just pick the one that's either, if it's already solved, great. If it's not, one of the easier ones to solve for. So what I'm going to do is I'm going to take this second equation here, this negative x plus 6y equals 8, and I'm going to get it solved for x. So I'm going to subtract 6y from both sides. I have negative x equals 8 minus 6y. Now I need to have positive x though, so I'm going to divide everything through by that negative 1. So x is equal to negative 8 plus 6y. Now what I'm going to do is in place of x in the first equation, instead of writing x, I'm going to write negative 8 plus 6y. So we have 2 times x, but x is negative 8 plus 6y. And then we have plus 5y equals 1. The point is you have to take the one equation and plug it into the other equation. So I'm going to distribute here. Negative 16 plus 12y plus 5y equals 1. If I add 16 to the other side and then combine my y's here, I have 17y equals 17. So when I divide both sides by 17, y is equal to 1. Now I'm going to take this value and plug it in over here, because now I can solve for x. X is negative 8 plus 6y. Well, y is 1. So negative 8 plus 6 is negative 2. So final answer here is negative 2, 1. When I look at B, I already see my second equation here is solved for y. So I can take this 2x plus 7 and put it in place of y for the first equation. So instead of writing 2x minus 3y, well, in place of y, I'm going to put 2x plus 7. And then that's still equal to negative 13. So we'll distribute out. Negative 3 times 2x is negative 6x. Negative 3 times 7 is, negative 21 equals negative 13. So if I add these two together, I get negative 4x. I need to add 21 to the other side. If I have negative 13 and I add 21, I'm left with 8. So negative 4x equals 8. When I divide by negative 4, x is negative 2. So I'm going to take that negative 2 and plug that back in for the y equals 2x plus 7. Well, if x is negative 2, we're going to plug that in. 2 times negative 2 is negative 4, plus 7 is 3. So the solution for this one is negative 2, 3. So the next method we're going to use is called addition, or maybe more common for you is called elimination. In order for elimination to work, you need to look at one of your pairs of variables. You want to stacked perfectly, x over x, y over y, number over number. And you want to have either your x's or your y's to be exact opposites of each other. So maybe you have 5x and negative 5x, or 8y and negative 8y. That's going to set up the equation so that we can use this elimination method. So looking at the first problem, 2x minus 7y equals 2. 3x plus y equals negative 20. So right now, the x's are not opposites of each other. The y's are not exact opposites of each other. So what I have to do is I'm going to multiply one of the equations by a number so that I can make them be exact opposites. If I look at the y's, I have negative 7y in the top equation and positive y in the bottom of the equation. So if I multiply everything in this bottom equation by 7, I'm going to have exact opposites in my y's. So let's take a look. I'm going to carry that top equation over. 2x minus 7y equals 2. I'm going to multiply everything in the bottom equation by 7. So this now becomes 21x plus 7y equals negative 140. And it's okay that I did that, because as long as I multiply everything through by that number, I have kept this as an equivalent statement. Now, if you look at the y's, I have negative 7y and positive 7y. If I were to add top to bottom, the y's are going to cancel out. So watch what happens. 2x plus 21x is 23x. Negative 7y plus 7y is no y's. 2 plus negative 140 is negative 138. So now I have an equation that's just x's. Well, I can easily solve that by dividing everything through by 23. I get x is equal to negative 6. Once I have the one variable, all I have to do is plug that back in to either of my two equations to find y. So let's take that top equation. 2x, so 2 times negative 6 minus 7y has to equal 2. So it makes negative 12 minus 7y equals 2. If I add 12 to both sides, negative 7y equals 14. And then I can divide by negative 7 to get y as negative 2. So the final answer is always x comma y, so negative 6, negative 2. All right, next one, we have 2y equals 8 minus 3x, and 5x equals 6y plus 40. So the first problem I see is they are not lined up correctly. We always want to have all the variables on the left side and the numbers on the right side. So what I need to do is I need to move this negative 3x back to the other side. So it's going to come add 3x. So 3x plus 2y equals 8. And then on the bottom equation, I need to bring the 6y back. So if I'm going to bring it to the other side, it's going to subtract. So 5x minus 6y equals 40. So I always want to look for that pair where one of them is positive and one of them is negative. And that's with my y's right now. So I have 2y and negative 6y. So they're opposite signs, but they're not the same number yet. However, if I multiply this top equation by 3, 3 times 2 is 6y. That will cancel out with my negative 6y. So working here, if I multiply everything through by 3, 9x plus 6y equals 24. And keeping the bottom the same, 5x minus 6y equals 40. I can then vertically add 9x plus 5x is 14x. 6y plus negative 6y is no y's left over. 24 plus 40 is 64. And if I divide by 14, I've got 64 over 14. They can both be divided by 2, 32 over 7. Now, you're going to realize not all of these work out to be nice round answers, and that's okay. We will do our best to work with what we got. All right, so I'm going to use this bottom equation. It really doesn't matter. 5x, so 5 times 32 over 7 minus 6y equals 40. All right, so 5 times 32, that's 160 over 7 minus 6y equals 40. So I'm going to subtract the 160 over 7. And here's where a scientific calculator is helpful. You can do 40 minus 160 over 7, and you can get that as a fraction. You may get it as a decimal first and then need to turn it back into a fraction, and that's okay. So if I move that over, I've got negative, nope, it's going to be positive 120 over 7. So 40 minus 167ths gives me 120 And then what I need to do is divide that answer by negative 6. And again, use a scientific calculator. You're going to end up with negative 20 over 7 as your final answer. So final solution, 32/7 and negative 20/7. So again, if you're ever working with those fractions, grab your scientific calculator. You can type exactly what it says, 40 minus 160 over 7. You may get a decimal. Then you can change it back into a fraction. If you're on the TI, you're going to hit the math and then hit enter twice. If you're on Desmos, you're just going to hit that little fraction bar. And then take that result, divide by negative 6, and do that same thing again. So TI calculator, hit math, enter twice. Or Desmos, when you do that, click that little fraction bar. So far, all of the solving ones by substitution and addition have come up with a single solution. Now, we know though that isn't always going to be the case. We know that we may end up with a set of parallel lines and end up with what is called an inconsistent system. They're not going to intersect. We may also come up where we get a dependent system or that the two equations are actually identical. So what is that going to look like when we go to solve these? And how are we going to know how to write the answer? Well, we're going to see that on the next slide. All right, so we have to identify which of these are inconsistent and which one is a dependent based off of what happens when we go about solving them. Now, at this point, you have the option to either continue with the elimination method or go back to substitution. It's totally up to you. So I'm going to try to show both ways here. Let's say in this first one, I see that this bottom equation here, so we've got 3x minus 3y equals 6 and 2x equals 2y plus 4. I see in this bottom equation here that it's almost solved for x. If I just divide everything through by 2, I get x equals y plus 2. So I'm going to plug that into the top equation. So 3, instead of x, I'm going to write y plus 2. Carry everything else, minus 3y equals 6. So I multiply out here, I get 3y plus 6 minus 3y equals 6. Well, 3y minus 3y makes no y's, so then I'm left with 6 equals 6, which is a true statement. So if you simplify completely and you end up with a true statement, we have what is called a dependent system. And that system is going to have multiple solutions based off of this equation here. X is equal to y plus 2. So anything that I plug in for y plus 2 for my x, so if I write it as a point, x is y plus 2, y is y. So whatever I plug in here, let's say it's 5, the x is going to be 7. 2 more than that. If this is 0, it's 2. It's going to give me multiple different solutions. Now, let's say you were looking at this and said, well, I didn't want to do substitution. Okay, that's fine. We can do the addition method. So I'm going to line them up here. So 3x minus 3y equals 6. And then that's going to be 2x minus 2y equals 4. So what I see right now is neither of the x's match, neither of the y's match. So what I'm going to have to do is, in this case, multiply both equations. Here's why. There's nothing I can multiply 2 by to turn it into 3. It's just not possible. So what I do is I multiply by the opposite number. So the 2 is going to multiply to the top equation. The 3 is going to multiply to the bottom equation. The only thing is I need one of them to be positive and one of them to be negative. So you make your pick. I'm going to make the top one negative. All right, so when I multiply through, negative 6x plus 6y equals negative 12. And then on bottom, that's going to make 6x minus 6y equals 12. Now, if I add all the way down, negative 6x and 6x makes 0. 6y minus 6y makes 0. Negative 12 plus 12 makes 0. Everything cancels out, and I again get a true statement. 0 equals 0. So 0 equals 0 means I have infinitely many solutions. I have a dependent system, and then I'm going to have to go back to what I did at the very beginning here and solving one of these equations for a variable. So that's how I've got that one there. Now, you could have also gone and solved for y, and then you're system would look a little bit differently here. So let me show you that real quick. Let's say I took that top equation, 3x minus 3y equals 6, and instead I solve for y. So subtract 3x from both sides. I've got negative 3y equals 6 minus 3x. And divide everything through by negative 3. So y is equal to, that's going to make negative 2 plus x. So this time, it's any x, and then y is negative 2 plus x. And you'll see we get the same pair of points. So what I set up here was if I had y be 0, then x would be 2. So one of the points would be 0, 2. 2, 0, I'm sorry. And that works here. So if x is 2, negative 2 plus 2 is 0. So they both get me those same pairs of points. All right, so that's a dependent, which means the next one's probably going to be considered inconsistent. So I'm going to solve this one using the elimination method. I have 2x minus y equals negative 4 and 4x minus 2y equals 6. So I'm going to, let's see, I'm going to work with the y's. I need, let's see, this is negative 2, this is negative 1. So let's multiply the top one by negative 2 because that'll make this 2y a positive 2y. So negative 4x, that's going to make plus 2y and equals 8. And then the bottom one, 4x minus 2y equals 6. So when I add these by elimination here, negative 4x plus 4x is no x's. 2y minus 2y is 0. So there's nothing left on this left-hand side. But on the right-hand side, I end up with 8 plus 6, which is 14. So now you see here, this is a false statement. This cannot happen. 0 can never equal 14. So this is a no solution, meaning it is inconsistent. Okay, a similar result would happen had I tried to use substitution. You're going to get to a point where all your x's and y's cancel out and you're left with numbers that do not equal each other. Okay, so I could do that if you wanted me to. So 2x minus y equals negative 4. Let's say I solve this equation for y. So I'm going to subtract 2x. Negative y equals negative 4 minus 2x. Divide everything through by negative 1. Y is 4 plus 2x. So I'm going to plug 4 plus 2x in for y of the other equation. So 4x minus 2 times 4 plus 2x equals 6. So we've got 4x. That's going to make minus 8 minus 4x equals 6. Well, 4x minus 4x is 0, and I get negative 8 equals 6, which again is false, telling me I have no solution or an inconsistent system. Okay, so parallel lines are your inconsistent. They will not intersect. They have no solution. If they intersect one time, we will get a single solution. If your lines are exactly the same, we get this dependent system up here where we can get multiple solutions and we can write our equation or our solution in terms of our variables.